Okay, for topic 3, we're going to talk about signs of trigonometric functions in a given quadrant. This is actually going to be a really big deal. Again, I keep telling you, we're building to this idea of a unit circle. And when you see the unit circle, I think all of this is going to come together much nicer, and it'll give you like this kind of visual understanding of all the things we've been talking about. But for now, just know that trig functions are going to have different signs depending on the quadrant that you're in. So like wherever the terminal side of your angle is, whatever quadrant you're in, that's going to matter based on whether you have sine, cosine, tangent, cosecant, secant, or cotangent. So they're all going to have different signs in different quadrants, okay? So we need to remind ourselves of a couple of things, and then we're going to go and we're going to do a little bit of side work here just to make sure we're all good. So this is going to take a little bit, but I think it'll be worth it. Okay, so recall the points in each quadrant on a Cartesian plane have a specific sign. So please recall and remember that this is quadrant 1. Okay, this is quadrant 2, this is quadrant 3, this is quadrant 4. Okay, if you're in quadrant 1, the x and the y coordinates are positive. If you're in quadrant 2, the x is negative and the y is positive. So we get negative, positive. If you're in quadrant 3, they're both negative, so negative, negative. And then if you're in quadrant 4, the x is positive, but the y is negative. Okay, so that's what we need to remember first. Now, by the definition at the beginning of this worksheet, we had that we have some point on the terminal side of the angle that's in standard position, and we called that point AB, okay? Well, the x value, so think of the x value as A and the y value as B, they represented something. So when we had that point on the terminal side of our standard position angle, we were finding that the A coordinate or the x coordinate coincided with cosine, and the b coordinate or the y coordinate coincided with sine. Okay, so again, that's given the point A, B, which is really just x, y. Now, I think I have a typo here. This should really just say that r is greater than 0. So fix that, okay? So r is greater than 0, okay? And what was happening here, let me draw this angle just kind of down here. So we have some angle. We don't know what it is. We just know it's in standard position and it's open as such, and it has some point A, B on the terminal side, and we know the distance from the origin to that point on the terminal side is R. And we said, hey, that point on the terminal side can be anything but the origin. So because it can't be the origin, there has to be some positive distance between the origin and that point. Therefore, R is positive. So keep that in mind, okay? So let's go back and remember all of those ratios from the table at the very beginning of this worksheet, okay? So sine is B over R. Well, if we're in quadrant 1, sine has a positive sign because B is positive, so we get positive A over positive B, okay? So sine of whatever, theta, is B over R, which is positive. Cosine was A over R, which is also positive. A is positive, R is positive. Tangent was B over A. Since A and B are both positive, that makes tangent positive. And then we have the reciprocal function. So we have cosecant. Well, if sine is positive, so is cosecant. We have secant. Well, it's the reciprocal of cosine, so if cosine is positive, so is secant. And then cotangent is the reciprocal of tangent, so if tangent's positive, so is cotangent. So in quadrant 1, everything is positive, so all positive, okay? Now, if we go into quadrant 2, A is now negative and B is positive. So we have sine of theta, which is B over R. B is positive, R is positive, so sine is positive. And remember, cosecant is the reciprocal of sine. If sine is positive, cosecant is positive. Now, cosine of theta is A over R, but in this case, A is negative. So we get negative A over R, which makes cosine negative. And remember, secant is the reciprocal of cosine. So if cosine is negative, secant is negative. Okay. Now, tangent is B over A, but A is negative. So now we get a positive divided by a negative, so tangent is negative. And cotangent is the reciprocal of tangent. So if tangent is negative, cotangent is also negative. So if we're in quadrant two, we have sine is positive. And remember, if sine is positive, cosecant is as well. Now, if we go down to quadrant three, both A and B are negative. So we get negative A, negative B. So let's go through this again. So sine of theta is going to be negative b over r, making sine negative. And remember, if sine is negative, cosecant is negative. Cosine of theta is negative a over r, making cosine negative. And remember, if cosine is negative, secant is negative because it's the reciprocal. And then tangent is b over a. So that would be negative b over negative a, making tangent positive. And remember, cotangent is the reciprocal of tangent. So if tangent's positive, cotangent is positive. So if we're in quadrant three, tangent is positive. Okay? Now, really quickly, let's look at quadrant four. So if we're in quadrant four, the a coordinate is positive and the b coordinate is negative. So we already know that sine of theta is b, which is negative b over r. So sine is negative. And if cosine is negative, cosecant is as well. Now cosine of theta is a over r. A is positive, r is positive, so that means cosine is positive. And remember, if cosine is positive, its reciprocal secant is as well. Tangent of theta is negative b over positive a. So we have different signs here making tangent negative. And remember, whatever tangent is, cotangent is going to follow along since it's the reciprocal. So cotangent is also negative. So if we're in quadrant four, cosine is positive. Okay. Now, I love when there's something silly that we can remember. Okay. So, like, if you go back, like, way back when you're learning the order of operations, we have PEMDAS, or please excuse my dear Aunt Sally. I don't remember what do you call those, mnemonics or something. We have one of those to remember this. It is all students take calculus. Okay. So, all students take calculus. Okay. Everything is positive in quadrant one. Sine is positive in quadrant two. Tangent is positive in quadrant three. Cosine is positive in quadrant four. So that's one way we can remember this. Think A in all for all, S in students for sine, T in take for tangent, C in calculus for cosine. And that's how you can remember this. Okay. So I know that was a little bit tedious working through all that, but I think it's worthwhile. Okay. Now let's come down here. It says in example 5, consider the 6 main trigonometric functions. Label each quadrant with the trigonometric functions that are positive. So let's see if we can remember this. Remember, all students take calculus. All right. So in quadrant 1, everything is positive. In quadrant 2, sine is positive, therefore cosecant is also positive. In quadrant 3, tangent is positive, therefore cotan is positive. And then in quadrant 4, cosine is positive, therefore secant is also positive. And remember, the therefore cosecant, therefore cotangent, therefore secant, it's because cosecant is the reciprocal of sine. So if sine is positive, so is cosecant, and so on. Now, in part B, it says label each quadrant with the trigonometric functions that are negative. Well, if everything is positive in quadrant 1, nothing is negative. So we would say nothing. Now, in quadrant 2, sine and cosine are positive. That means cosine, or whoa, in quadrant 2, sine and cosecant are positive. That means cosine and secant, and then tangent and cotangent are negative. Okay? If we go to quadrant 3, tangent and cotangent are positive, which means cosine and secant, and then sine and cosecant are negative. And then in quadrant 4, we know that that calculus is positive. Good Lord. We know that cosine and secant are positive, which means sine and cosecant are negative. Tangent and cotangent are negative. Okay. You really do need to remember this. Okay. You need to remember which trigonometric functions are positive or negative in each of these quadrants. Okay. So try to remember all students take calculus. Okay. Now we've got example 6 here. So example 6 says, name the quadrant that meets the given criteria. Okay. So for part A, it says, name the quadrant in which the angle theta lies if sine of theta is positive and cotangent of theta is negative. So let's see, where is sine of theta positive? Well, sine of theta is positive in quadrant 1. Everything's positive in quadrant 1. And then again in quadrant 2. Cotan of theta is negative. Okay. Well, nothing is negative in quadrant 1. Okay. Cotangent is going to be negative where sine and cosine have different signs. So I know that in quadrant 2, sine is positive, cosine's negative, which makes cotangent negative. Quadrant 3, sine and cosine are both negative, so cotangent would be positive. And then in quadrant 4, sine is negative, cosine is positive, so that would mean in quadrants 2 and quadrants 4. So basically, where do we have overlap? We know where sine is positive. We know where cotangent is negative. We have one angle that has to meet both criteria. So where do we have overlap? We have overlap in quadrant 2. So that tells me theta is in quadrant 2. Okay, now let's look at part B. In part B, it says name the quadrant in which the angle theta lies. We know that cosine is positive and tangent is negative. So where is cosine positive? Forgot my theta. So cosine of theta is positive. Well, let's write actually positive. It's late, bless my heart, okay? Well, everything is positive in quadrant 1. So we know cosine is positive in quadrant 1. Once we go to the quadrant 2, cosine is negative. Cosine is negative in quadrant 3. In quadrant 4, cosine becomes positive again. Okay. And then we want to know, where is tangent of theta negative, so less than 0. Well, nothing is negative in quadrant 1, okay? In quadrant 3, cosine and sine are negative, which means tangent would be positive. So that would tell me that in quadrant 2 and quadrant 4, tangent is negative. Okay, so where do we have overlap? Well, we have overlap now in quadrant 4. So quadrant 4 is where cosine is positive and tangent is negative. So we would say theta is in quadrant 4. Okay, and that is going to be important. You're going to see a couple of examples where we get criteria for an angle and we have to know the sign of the angle or the sign of the trig functions in that particular quadrant. Okay, so that's it for the signs of, the signs of the different trig functions. It really is important. This is going to be something that comes up. I think it's a little bit easier to understand when we start talking about the unit circle, which is very, very soon, but really understand which quadrants each trig function is positive or negative. Okay, it's going to take you a long way.